Tēnā koutou katoa, no Aotearoa o Whanganui a Tara, aho. Ko aho te product architect ki RedShield. Ko aho OWASP o Whanganui a Tara. Ko Kirk Jackson, tōku ingoa. Tēnā koutou, tēnā koutou, tēnā koutou katoa. Welcome everyone. My name is Kirk. I hail from Wellington. I'm a product architect at RedShield. And I also help organize the OWASP Wellington meetup. And today, we're going to talk about Log4Shell and the ModSecurity Core Rule Set. Also, about how long is that title of the talk? Pretty cool. I don't think I've ever had so many letters to fit on one slide. So you may have seen some of the Log4Shell stuff. Maybe you had to deal with it in your job. And I thought I'd just kind of like wrap it up into a bundle. It would have made more sense doing this talk in February, but you know, it is what it is. It's July. Cool. So also in this talk, I get to reuse, before that, sorry, thank you to all our sponsors for their support and making today happen. I get to reuse my favorite animated slide deck, or the first 400 animation transitions from a previous slide deck. And we'll start off talking about how you build a secure web app. So you've got this idea, and you want to build a website. You want to build an application and make some money. So you do a bit of a software development process, and you put your web app on the web server. You're like, well, I can't keep that under my desk. I probably need to put it in a hosting environment. So you buy some space in production environment and you put a firewall and you open ports to your web server. And then you want to sell the app. So you need to accept credit cards, which means you need to follow PCI, which means you need a web application firewall. And you want to have AV because PCI says you have to. And then you need to have egress filtering. So you have an outbound proxy. Cool, app's ready for production. Not quite. Because you need to have an intrusion detection system and data loss prevention system. You need to make sure you can manage the users that are using the environment, identity and access management, and you want some kind of config agent to make sure that your machines are configured properly. And you want to send all that data to a SIEM. Sweet. So that's kind of the, oh no, it's not. Because you want to train your developers, because if you build software that's insecure, it's going to be insecure in production. So send them along to OWASP events. But then you need to get someone to do some reviews, maybe peer reviews. Maybe you want to do some threat modeling early in the design phase. Maybe you want to do some static analysis of your code. Maybe some dynamic analysis using OWASP ZAP or something like that. I forgot what IS stands for, Interactive Application Security Testing. And maybe you'd actually do some specific security testing. You've got an internal team trained to use security testing tools. So now your app's secure. Oh wait, no it's not. Why is my slide not clicking? I'm right next to the keyboard, I can do this myself. Now you need to make sure that your operating system is hardened, have patch management policies and processes that you follow, that you've got file integrity monitoring so you can discover if someone's modified files on your web server. You need to have some kind of governance process that makes sure that when people arrive, when they leave, when they change roles, that the access rights change. Maybe you need a configuration management process. You might need some cloud workflow protection to make sure that the servers in your environment are actually configured correctly and that the logs are being pulled centrally. You probably need some automation because you can't just copy zip files onto web servers. It's the year 2022. We need to use pipelines for that. And you actually need someone to look at the logs from all of these tools and make sure that there's no issues. And you need policies and you need standard operating procedures. So now you're secure, right? Cool, okay, so we can get on to the rest of the talk. Oh no, hang on, we need to get a third party in to check that we've done everything. Maybe we'll get some vulnerability scans done, someone to do an external configuration review. Maybe we'll pay for pen testing. there might actually be real attacks that will do security tests for us for free. Now we're secure. We've got the building it securely stuff pretty nailed. We've got the hosting it securely stuff pretty sorted. And we've had someone come in and verify it's secure. Some of them we even paid to do it. So how much did that cost to take your idea that you had and put it in production? So I don't know, number 42 is a nice number, but 42 million seemed too high. I think 4.2 sounds about right. Yeah, it's a big deal getting an app into production, and security is hard. So that's not what your enterprise looks like, though. As well as that app, you have the other apps that your company builds. They have to all be kept secure. And you've got your corporate environment, which is not really a physical network these days. It's a collection of roaming devices such as desktops, servers, Active Directory, mail servers, mobile devices, your CEO's iPad that doesn't fit any of the standards. And then, of course, all the cloud things that your production environment connects to and that your users use in the corporate environment, all of that needs to be secure. So it's kind of mind-blowing how much stuff we have to think about. Okay, I'm going to make the cloud stuff smaller because I don't like that picture very much. And I like black and white aesthetics. So, okay, so your organization's kind of like this. Probably in your head, you're like, yeah, this makes sense. We actually have more applications that we develop, and our corporate environment's more complicated, and we have a parent company. But, you know, representative. Okay, so say your organization looks something like this, and a user sent, no, I need to phrase this a different way. How many possible ways could a 30-character string enter your environment? Oh, that was rhetorical, I guess, because no one answered. Yeah, let's pretend that was rhetorical. So let's say 42 million, right? So people could type into web apps that you've built, emails come in, could have that string in it, files that are sent could have an image, the image metadata could have it. You know, there's a myriad of ways that a 30-character string can enter your organization. Now, what if I was to tell you that one 30-character string could enter your organization through any of those ways, and somewhere else in your organization an attacker's code would run? And that's what Log4Shell was, the Log4j vulnerability from December. A very small snippet of text from an attacker entered somewhere into your ecosystem, chat client for Minecraft, email, web apps, I don't know, DNS responses, anywhere that entered your organization, and then somewhere else in your organization, eventually, days later, weeks later, the attacker's exploit would run and get a shell. Kind of terrifying, and this is why I did nothing when this was tweeted. Because it was my birthday, and I don't say this because I want you all to tweet at me on my birthday, because that would be creepy, but just as an explanation for why I wasn't reading Twitter, I'll try doing that. So this is the first public mention I could see of the Log4j JNDI vulnerability on Twitter, 3 a.m. New Zealand time. A little bit later in the day, 4:30 a.m., someone posted a GitHub remote code exploit example. Later in the day, New Zealand time, 6:20 p.m., CertNZ issued an advisory. I think I was out for dinner at this time. It was very nice. Something that I thought was nice is that CertNZ, like the government department responsible for protecting our country, uses Twitter for iPhone, which I think is good, because we all use Twitter for iPhone. That's good. And also quite good that they were working in the evening and could post out this advisory. And this was the first time a lot of companies heard about it. And lucky for New Zealand, we were awake at 6:20 p.m. On a Friday. I mean, we probably weren't at our work desks, but a lot of countries overseas, they were asleep at the time. So here's the kind of timeline of this vulnerability. So actually it starts 13 years prior when the JNDI feature was added to Log4j. But on November 24th, a security researcher from Alibaba discovered a vulnerability and reported it. On December 6th, another CVE was issued. And then by the 10th, the proof of concept was public. Log4j followed up. It's an open source project. The team issued multiple releases. And of course, as everyone's eyes turned to the Log4j project, more issues were found. And so they had to do a few releases. I think there was one on Christmas Eve. I remember checking something after lunch on Christmas Day just to check. And it was generally a bit of a shitty month. Matthew Prince, who's the CEO and founder of Cloudflare, said that they did log analysis and found the first Log4j exploits hitting their Cloudflare web servers back on the 1st of December. So somehow people figured it out in advance of the broader public. And I can't get the timeline, but at some point between the 1st and the 10th, a lot of kids started hacking each other on Minecraft. So yeah, that's kind of our timeline. What else is interesting? Oh yeah, so those are New Zealand times, as far as I can tell. It was a day before there was a release that fixed it, and then everyone needed to patch, and then a few days later they needed to patch again, which was painful. And you know, the annoying thing was you had to try and patch Log4j everywhere in your entire organization. Sorry about that, hope you didn't get dizzy. Okay, so what is Log4j? So it's a logging and tracing library, and it's very popular in Java applications. Someone guessed 80%, and then I tried to look and back that up, and I couldn't find anything. But has anyone here used Log4j in their Java app? Yeah, so I have as well. It's been around since the early 2000s. It's a really good library for writing out log messages from your applications with different severity levels and then filtering the output. So yeah, it's an open source project. It's now taken over, or it's now underneath the auspices of the Apache Software Foundation. Oh yeah, look, there we go, 21 years old. Cool. Is there anyone in the audience younger than Log4j? Please don't say yes. Okay. Cool. So Log4j has a bunch of features, and one of them is that it does property substitution. So you probably can't quite see this, but there's a bundle of different keywords you can use, and you put them inside curly brackets with $, and instead of that string being logged, the keyword gets evaluated and substituted. So this one puts the date into your message. This one puts an environment variable, which is the current user. This one takes something out of the thread context storage. I think I got that terminology wrong. And there's other keywords such as getting the JVM run arguments, getting a value from map message, whatever that is. I guess it's something to do with maps. And bundles, base 64. And so this is a feature of Log4j that when you're inserting your debug messages, you can manipulate the strings that it's writing. It's kind of a handy feature. Unfortunately, one of the items on the list is JNDI. And JNDI has been around for a very long time. It's the Java Naming and Directory Interface, which is an API to look at a directory service, give it a key, and get back a Java object. Sounds like a great idea. So typically you'll use it with LDAP. So you'll say, get me my config from LDAP, and here's the name of my app. Maybe that's the key, and it'll return a Java object with the config. You might use it to look up users. It's kind of like a remote object access protocol, I guess. As well as LDAP, you can use DNS, Corba, and NIS, which I think are things that old people know about. I'm an old person. And what JNDI does is, what Log4J does when you put a curly bracket with a JNDI string in it is it resolves the domain name. So here it's ldap.spearfish, which is a domain of mine. Where's the animation? Anyway, gets an IP address for that domain name, creates a TCP connection, makes an LDAP request over that connection, and gets back a Java class file. And then the application loads that class file into memory and runs it. So essentially, it remotely loads code and then executes it, which is not awesome in all circumstances. So where did I put that slide there? Yeah, so here's an example. This may be based on a true story, but it's not because I made it up. So say you use a SaaS HR system, employees upload CVs. The CV contains a file, and the file name of that file, that file has an image in it because it's a Word doc, and the JPEG has the name JNDI, blah, blah, blah. So we're like several levels deep, right? Then that HR system does a webhook post to a system in your data center. You store the CV in a database. Then you send an email to the HR consultant within your company with the CV attached. They right-click it and save it to their desktop. Antivirus kicks off, and you use a cloud AV, and it logs all the files that it's scanning. So it unpacks the Word document, scans all the images inside it, logs all the names of them. And then you've got some custom code that you've written which goes across your AV search results and tries to pull them into your SIEM. And so you're doing some log analysis, and you're writing all the file names to log files. So that's the missing link. That's not the missing link, that's the weak link. That process happens to use Log4J to write the log entries to the SIEM. So an example of this could be just something simple like, hey, this file alerted, and then putting the file name into the log message. And because the attacker put that JNDI string in, Log4J resolves it, looks up the IP address of the domain name, and DNS gets back the IP address. Then it does an LDAP request by connecting to that IP address on the LDAP port, gets back a redirect saying, hey, go here for your class file. So it makes an HTTP request to a web server, which returns an exploit.class file, which is compiled Java code, pauses for dramatic effect, and runs the exploit class. And then that exploit class basically runs a reverse shell inside the Java process, connects out to the attacker's environment, and allows them to proxy request back. So it's kind of insane, right, that a file uploaded into a HR system could end up with your SIEM running Java and having a remote shell to it. And like, think of all the permutations of all the possible ways that 30-character string could get into your business. Kind of amazing. I think someone said it's like one of the biggest things, to drop in terms of web vulnerabilities, or just in terms of vulnerabilities. And that's why people worked in the weekend. So what started happening? Well, people started writing scanners to find vulnerable Log4j environments, and there's proof of concept exploits, and attackers are pretty fast at picking up on these. So the typical scanners that I saw, at least, followed the same approach. So they'd pass a string into your application. Your application would do a DNS request to resolve the domain name. So the attacker could detect if their domain name server got any requests for the domain name they gave in their attack. So example of that would be my spearfish domain. My DNS server might notice that this was looked up. Attackers could set up, so that's probably enough just to scan if someone's vulnerable. Like if you give them a string and then your domain name server pings, that probably means that it's running the attack. But then they also could set up a dummy LDAP server that returns a Java object and then they could write their own code. Some people actually wrote like inoculation scripts. They set up all this infrastructure, but instead of initiating a remote shell, it would patch the Java application on the fly to remove the vulnerability, which is pretty cool. So demo time. So the bit that I'm not going to do in this demo is I'm not going to do the bits that got removed from GitHub when people posted them. I'm just going to show the scanning part, just seeing DNS requests. I don't actually remember how to write Java. The last professional Java gig ended in 2000 for me. Yep, I'm pretty old. But luckily someone made a Spring Boot app, and it's really simple, so even I can figure out how it works. Basically, if someone connects to the URL / and they include a header, then the app returns hello world in the browser. So if I find my browser, oops, I better run the app. And the even nicer thing about this demo app is I don't need to install Java on my computer to run it or mess around. So the app runs, if I pass the right header, it will give a message. So let's change the request to pass the right header. So I'm just using a tool called Burp, which just lets you modify your requests. I think it was X API version hello. So let's go back to the app. Okay, that's interesting. The hello got output to the log of the web app. So let's go look at that code again. Oh yeah, before it returns hello world, it logs something. It logs received a request for API version and then the version string that was passed in on that header. Okay, and it's using Log4J to do it. Dun, dun, dun. So next thing we'll do, let's just start up a DNS server because otherwise I'll forget. Okay, first thing we're going to do is connect to the internet. The internet is a wonderful invention that's been around since before Log4j. Cool, so I'm really lazy, so I'm just using this product called DNS Mask, which just you can run on the command line. And it's probably big enough in this room for you to read the bottom of the screen. So if I look up my domain, I have privacy. Look at all my privacy. That's how you can tell I'm a bad person. I have 2 domain name records. They both point at this EC2 instance. So if I look up any old thing.spare.fish, the host command is just trying a couple of queries. It's asking for an A record, a quad A record, and a mail server record, MX record. And then my DNS server is returning an IP address. Cool, so, okay, DNS, yep. I think we've seen DNS before. Okay, so let's try and do some attackery things. So the first thing we want to do, I guess, is try some of those kind of benign Log4j attacks. One of them, oops, lets you look at environment variables, and I happen to write that down, so let's do that. If we go back to our running web app, let's get rid of that one. Instead of outputting request for API version $env path, it's actually substituted it with the path of the application. So if there was other sensitive stuff in the environment, like it was a web app and it had secrets or database credentials or whatever, could access those. But they're getting output to the log. They're not getting sent remotely to the attacker, which is what we want to do. Do I have any other nifty examples? Not really. But anything that was on that slide, so lowercase, uppercase, base 64, all that stuff works. I just need to send it from my browser, and the application is logging that string and expanding it. So let's try the JNDI attack. I should copy and paste this rather than typing it. Thanks. I actually had my eyes lasered, so I'm not missing an eye, but they're not quite as good as glasses. If I'm an attacker and I want to send lots of requests to different web servers, I'll use a random domain name for each web server that I send it to, and that way I'll know which one is vulnerable. Because like we saw before, the pingback could happen later, like months later, days later. So it's not going to be like you send a string to an application and straight away. It could be the HR person has to download that file and antivirus has to run before it happens. Let's see if I did that right. We should get a request to that domain name. Yeah, I think that's it. And also we get the IP address of who just called out to us, which was this application. Now I don't have an LDAP server running, serving up exploit Java code. That project is available. It's not on GitHub anymore, but the Internet Archive, etc. But you can see that we're one step away from that, and plus that's enough time for the demo. Cool. So that's the Log4j vulnerability. One of these is that. So if you came along to my intro session to the OWASP Top 10, you might remember this slide. It's an injection attack. It's an attacker sending data to an application, and instead of treating it as data, you're treating it as code, or you're allowing some code to run. So it's very similar to SQL injection or cross-site scripting. So yeah, that is another kind of injection attack. So who fared well on the 10th of December? Well, I did, because I had dinner out. But starting from midnight on the 11th of December, I was working. Companies that did well, sorry, I was just trying to look at what time I was supposed to finish, 2:20. Companies that did well were ones that have some other protections that just happen to catch activity and alert their teams. So logging all DNS requests from the production environment and looking for anomalies. Like often your web server doesn't actually make requests out to things. So if it's doing domain name lookups, that might be a bad sign. Strict firewall rules. So you might want to block all outbound connections from your web server, only allow inbound. Maybe look for suspicious port requests, like if you're a Unix environment, maybe you don't connect out to random LDAP servers. So that might help you block or detect the attacks. Maybe you have something that detects the unusual behavior that reverse shell causes. Or maybe you are able to react quickly. And companies that had a really good inventory of all their systems potentially were able to react better. I don't know if any of those companies exist, but it's really kicked off the conversation around inventory management and software bill of materials, understanding your dependencies, because you really want to be able to just push a button and to know everything that has Log4j in your environment, or push a button and have a list of everything that accepts strings in your environment. Yeah, I don't know if many people are at that nirvana yet, but it's definitely something we can hope for. So stopping Log4j attacks with a WAF. So I work for a company that uses WAFs. This talk's not about that, apart from the bit where I was awake, which was trying to help our customers. We're just going to talk about the OWASP ModSecurity Core Rule Set project and how their team helped people defend against this attack. So a WAF's not a perfect approach in this scenario. A WAF, if you don't know, is a proxy that sits in front of your web application, inspects requests, potentially inspects responses, and blocks traffic that's invalid. The reason why it's not perfect is it's only sitting in front of your web apps. And as we saw, there's 100 million other places that accept strings in your environment. And sometimes a WAF, even though it's in front of your web app and your web app is vulnerable, it's not a perfect defense anyway. So it's just a piece of cheese. Yeah, cool. Some of you might have been at the earlier talk by Steve. Okay, so it's just a piece of cheese. It's a piece of Swiss cheese that blocks some stuff, but we'll talk about the stuff that it can block. So what is the OWASP ModSecurity Core Rule Set? It's a project. There's about 12 active contributors. It's a pretty healthy project. And they develop a set of WAF rules to detect classes of vulnerabilities. So it's less about, Kirk's instance of WordPress has a plugin that has this issue on it, and here's a rule to block it, but more like deserialization attacks. Let's just block them in general. Let's stop cross-site scripting. Let's block SQL injection attacks. And these generic defenses often work against specific vulnerabilities. So the project is so successful that everyone else is making money out of it, apart from the project team, which I think is how open source works. So I'm not on the team, so I'm making jokes about other people who aren't here to defend themselves. So AWS WAF, Azure WAF, Fastly, they all have core rule set rules imported into their WAF products. I don't think they run ModSecurity, but they leverage the work that the team has done, as other products do as well. And the assertion is that it'll block sort of 80% of attacks, the low-hanging fruit stuff with minimal false positives, and then you can focus on the more specialized attacks. You might be wondering what's ModSecurity, and this is where the story takes a turn for the worse. So ModSecurity is an open source project where the only contributors are TrustWave Spider Labs, 2 employees who have announced end of life for their support for it, which is a real bummer. Hopefully a community will build up and take over, but the community's had difficulties interacting with TrustWave, so we'll see how that goes. There's a version 3, which is a rebuild of ModSecurity to work better in nginx, but it's slower than the version 2 that works faster in Apache. So ModSecurity it's a cool enough tool. It has this really complicated syntax for writing the rules because of its Apache background. So there's a nice book that Christian Fellini, who's one of the key contributors to the core rule set, has co-written. It's relatively readable. But yeah, I don't know, like this month, I probably wouldn't pick ModSecurity as my open source WAF of choice. There is a promise on the horizon with some kind of gopherish creature as its mascot, Coraza, which is a new WAF written in Golang that supports the ModSecurity rule syntax and the core rule set, and is aiming to be high performance and better support from the community. And the core rule set team is really hopeful that this will be the future of their project. So it's kind of funny, like a lot of open source projects, the people that build the engines or the standard libraries find it hard to get community support, whereas the people that build the layers on top that us developers interact with find it easier. But yeah, hopefully this project takes off. Or as I said, I guess the core rule set rules are still available in other commercial offerings. So what does it have? The core rule set has rules for all the common attacks, classes of attacks, SQL injection, cross-site scripting, local file inclusion, etc. They've focused on reducing false positives. So there's a trade-off between blocking everything that's potentially suspicious and annoying your CEO. And so it's aiming to have less false positives and potentially let some attacks through. But you can turn that up and down by setting your paranoia level. For example, here is a screenshot of how they detect cross-site scripting. It's actually a regular expression. And so this D here, no, just kidding. So I think it's actually, I can't remember what I screenshot there. It was quite hard to get it on my screen. I think it's one of the 27 regular expressions that detect cross-site scripting attacks. But the thing is, humans can't write this, so they actually have a tool that generates a higher performance regular expression. So, attacks that have similar substrings, it folds them together into conditions and stuff like that. So we don't have to think about that too much, but just know that it's funny to look at. And also regular expressions can't block every attack. So probably the only link to a research paper today, a formal axiom of validation. They proved that a regex validator can be bypassed. So for every regular expression, there's a way to get around it. So ModSecurity also has a kind of nifty approach called lib injection, which instead of using a regular expression, it uses like a parser that tries to parse JavaScript or SQL from the strings that it gets in, and if it finds keywords that match, and it kind of builds up a parse tree of a snippet of JavaScript or SQL, and if it finds enough of a snippet, it says this feels very JavaScript-y, and then ModSecurity and the core rule set can block it. So other stuff about the core rule set. So they've got a plugin-based architecture now, so that if you want to build your own rules, it's a bit easier to slot them in, and it's easier for the community to contribute rules, say for WordPress or Joomla or .NET or something like that. They've got a public sandbox, so you can test out your attacks against it. Just curl them to the sandbox and see what rules would trigger. And they've also changed the architecture of it to make it faster. So rather than running all the rules and then deciding to block at the end, if it finds something bad enough on an early rule, it'll just block early. The problems? Really daunting syntax. And it's not really something you want to learn mid-attack. It's probably not something you really want to learn. But I think having a WAF is a good idea, and I think this is a good project. So I would suggest it's worth it. Also, ModSecurity has some other limitations. It's hard to manipulate some parts of the response. It's version 3, like I said, was slower and has less features than version 2. So yeah, there's limitations. But what did the core rule set team do when Log4J came out? Well, the cool thing is they were on it just like everyone else, and they said, we've got this low confidence rule that you could turn on, like increase the paranoia on, that'll block some of these JNDI attacks. But then they iterated on regular expression-based rules to block the JNDI attacks. So the nice thing was, we were really lucky with this. Like, we could have been tasked with trying to detect any string, but actually the attacks that come into your applications have a pretty strict syntax in order to run this issue on Log4j. They need to have, damn, I'm talking out of order. They need to start with $curly bracket JNDI, essentially. We saw a lot of attacks that started off looking very simple like this, and so it was pretty easy to block them, like scanners. And then they pretty quickly adapted. So, you know, sometimes it's tempting when you see an attack to block just that attack, but that might buy you a few minutes of time, but then you need to go and figure out what the actual root cause issue is. And that's just something that I really enjoy doing. Go looking at the source code for projects and try and find out actually what can you give it to trigger it. And, you know, some of those early defenses that some companies put in, looking for JNDI : LDAP, well, there's actually other syntax. I think there was DNS, RMI, and Corba, those old people things. Or you might be tempted to say, well, it needs to have a closed curly bracket so I can search for open and close. But there's a whole bunch of other things that you can do in Log4j and other options. So it's quite hard if you had too specific a rule. So attackers quickly evaded them. So the first one, lowercases a capital J to get a lowercase j, and then does the LDAP lookup. That's another Log4j feature. This one looks up an empty environment variable, and if it doesn't exist, returns a j, another Log4j feature. That's just the same one, continuing on. Both of those actually, you know, simplify to this, which then simplifies to calling out. So yeah, as I was saying earlier, in the wrong place, this is the Log4j code. The string matcher class actually looks for a dollar exactly followed by a curly, and there's no like character sets or anything like that. Like it's all very simple, no white space in between. Unfortunately, a lot of apps use $curly, so if you just blocked that, you'd get false positives. So then the next realization was that all the evasions either have $curly JNDI or $curly with another $curly somewhere in the first little bit of the string. So there's the lowercase j, there's the environment lookup. So there's actually only 5 strings that we need to find to block this attack. I say block with a caveat, to detect this attack in these simple forms. And a WAF is really good at finding strings and requests. So that's why I guess this layer of cheese to block requests coming into our web app is relatively successful. And luckily, a regular expression to cover both of these cases, JNDI or dollar followed by a dollar within 4 characters, $curly followed by a $curly, doesn't seem to block much legitimate traffic to most web apps. So that's where the core rule set came in. They iterated on it a bit, but this was the rule that they ended up with sort of 3 days after, which does exactly that. So it looks for a $curly followed by 0 to 4 non-curlies followed by another $curly, or it looks for $curly : JNDI or CTX, which is another alternative. And I'll just talk a little bit about this rule. So there's a bit of stuff below it, which I've just removed. This part of the rule talks about which parts of the request to search. So ModSecurity can search the request line. It can search header values and names, cookie names and values, argument names and values. It can search XML. And for argument names and values, it also searches for them in the URL. And the nice thing about WAFs is they'll typically unencode stuff according to RFCs before they check it. So if I was just doing a simple string match, I wouldn't catch all these percent encoded versions of it, but the WAF would, because it knows that percent encoding is allowed to be used in a query string. But it doesn't stop application-specific issues. So say your application encodes data, like it uses base 64 encoding. Your WAF's not going to automatically know that it needs to decode that. There is a tool in ModSecurity where you could do that, but you'd need to know which fields of your apps use base 64 encoding, or SQL hex encoding, or CSS, or whatever the encoding is that your app is potentially smuggling text in. The other type of evasion, which works reasonably successfully, is to split the attack into 2 parts and put one in one place and one in the other. So here's an attack. So the application logs the first name and the last name, concatenating them together. So if I put $ as my first name in this application and curly JNDI as my last name, then my attack smuggles through, but ModSecurity doesn't find it because it's looking at individual parameters for that regular expression. And so that's why, one of the reasons why this is a slightly leaky slice of cheese. I hope you went to Steve's talk, because otherwise this is a really weird analogy. Because you don't normally have leaky cheese. I don't know, maybe some of that fancy French cheese leaks, but like good old mainland, that doesn't leak. So that's why, it's application specific how your app's doing it. And your application might be combining text in any way possible. It might be taking the URL off the query string and the $ out of the user agent and the J out of a cookie and the NDI. And if it just happens to log all them concatenated together, the exploit will run. So yeah, WAFs, don't fix everything. Bummer. And it's an interesting thought exercise into how you could potentially block this. I don't think it's possible, but without knowing the internals of how apps work. So yeah, so today we talked about web application firewalls and Log4J. Hopefully that was a fun introduction to the issue and why people thought it was a big deal. My advice to you as developers with security interest or the security team is to prepare in advance. So think about what protections you need. Oh man, I'm a minute over. Inline all the time. So, you know, when you're under attack, it's not the great time to figure out how to install ModSecurity, and to practice writing rules. Prepare the infrastructure in advance. And in summary, all that stuff I just said, but in shorter bullet points. Thank you.
Thank you, Kirk. Are there any questions for Kirk?
Do we have time?
We do have time.
Oh, you made me hurry up.
No, I showed you 5 minutes to go.
Okay, well, no, but you be quiet. Okay, so in summary, Log4Shell issues are really pervasive and like perverse, like not in that way, but you know, like just complicated way. And we got really lucky with Log4j. I don't think we should say we nailed it as an industry because we actually got hammered by it. And it was pretty much the simplest possible string that we could have detected. I mean, as far as detecting it coming in. And we still, as we can see, can't stop it. So we're unlikely to always be that lucky. And so patching is the important thing. And in order to do that, you need to have an inventory of everything. And as you know, applications being as they are that we build just have a lot of transitive dependencies, libraries that use libraries. Cool, and preparation is key. So with that, I have 2 minutes for questions. Is there any questions from the floor? Yeah. I can repeat it if you want to yell it out.
Just a quick question about the ModSecurity. Where can you actually use that in place of integrations of any integrated with the other WAFs, the whole core rule sets, or is it something like a standalone thing that you have to use it by itself?
Okay, so the question was, for ModSecurity, can you integrate the rules with other WAFs, or do you have to use it with ModSecurity? Yeah, I think as is, you've got ModSecurity and Coraza. I don't know if it's how to, you know, that new one that will take the rules as is. And then I think the commercial vendors translate those rules into their own syntax. So in AWS WAF, you can say include the core rule set. But you don't get to tune it as much as you do with your own ModSecurity. So yeah, I guess that's a trade-off. Yeah, cool. Any other questions? Any questions online?
No other questions.